Good morning students. This is our session 6. In session 6 we are going to learn about hardened concrete. Generally in last class we have learned about fresh concrete, how fresh concrete we are going to deal with. So after doing the plastic concrete we are going to go for the hardened concrete. So whatever the paste we have given as a fresh concrete, that will be hardened. So after getting hardened concrete, how we are going to test it, how we are going to see the properties of the concrete, strength of the concrete can be known in the session 6. So properties of hardened concrete: characteristic strength, drying shrinkage, creep, modulus of elasticity, permeability, resistance to chemical attack, and hardened time dependent properties of concrete that may influence the structural performance. We will discuss different properties of concrete below in detail. So we are going to learn about strength, compressive strength, tensile strength, durability. So in strength, in simple language, the strength of the concrete means the maximum amount of load which it can be handled. The common practice, the power of the concrete which considered its most valuable property. In fact, high strength concrete is synonymous with good quality concrete. The strength of the concrete can be determined by the compressive strength and the tensile strength. So compressive strength, what is compressive strength and how per unit area we are going to calculate, how the special care can be taken with the compressive strength. So with using certain cube strength, by using certain specimens like 5 days, 3 days, 7 days, 28 strength, we are going to cast it, we are going to see the samples, then only we go for the real construction to the. So it has been observed that compressive crushing strength of the concrete influenced by the huge number of factors. So some important factors are types of cement. So which type, aging of the cement, like tricalcium is more, like particle size is different, high strength is taken, or ordinary Portland cement you have taken, setting time has to be reduced. So based on the type of cement, the strength will be dependent. So nature of the aggregate, like sand, coarse aggregate, smooth, it's like fine aggregate to coarse aggregate. We are going to see smooth finish, rounded aggregate, for example chalk. If any lime content is more, the weakness of compressed concrete strength will be known. Water cement ratio, the compressive strength decreases in general and with increase with water cement ratio. So hence the minimum water has been used just to ensure complete hydration of the cement. The resulting concrete will give maximum strength. So the less the water we have used, the proper compaction which gives higher strength to the concrete. So curing conditions means we are going to water it with certain time so that they increase the strength. When water is interacted with the concrete, it enhances the strength of the concrete. So great importance as it is attached to proper curing of concrete after it is laying for obtaining maximum compressive strength. So incomplete curing and intermittent drying of concrete during curing period may cause a loss of compressive strength to the extent of 40% or even more. So based on the weathering conditions also, the strength of the hardened concrete may depend. The same concrete placed in different climate, extremely cold or hot, or depends on the strength values, which develops different strength values. So the cause is relatively to incomplete hydration of cement is called concrete. So admixtures, so different types of admixtures for air entering agents, for to increase the strength or for retaining, or to increase higher strength to the certain slabs or the retaining walls or some other things. We are going to use certain calcium chloride to increase the compressive strength to achieve certain purposes. We use proper, not maintain, when you are not using high water cement ratio in a correct form, the admixtures gives a certain added advantage to the concrete. So tensile strength, how we are going to see the tensile strength. The tensile strength can be known with the without steel reinforcement. There we can see the strength, and based on that we can see the different tensile strength of concrete becomes a valuable property when it is used for road mapping the runways, so it is determined by the indirect method. So the two methods are there, one is direct method and another one is indirect method. In one of such methods, the flexural strength test is been taken based on the beams, and the second one is indirect method, is a split cylindrical method where the specified dimensions made to fail under tensile and apply compression load across the diameter. It is left with splitting and tensile strength. So next one is durability. So durability can be depends on many things. When you listed down, there's a frost action, abrasion force, chemical action, alkali aggregate reactions is brief about in the below. So frost action means like high cold climate conditions, which is freezing the concrete pores cavities during extreme cold weather. So what are the conditions of the concrete? So to minimize the frost action measures that has to be taken in cold weather, the water cement ratio should be kept low as possible. This will not allow any extra water to remain within the concrete pores, hence frost formation will not be placed. So use good drainage and coverage method for removing any surface water from staying on the concrete during the curing process. So chemical attack means in environment concrete can be liable with any of the sources. So concrete is liable to attack various degrees by acids, alkalis or salt solutions. So generally if it is listed, they will destroy gradually the calcium hydroxide and components of concrete used for sewage disposal. Other acids may attack the concrete used in industrial building of assets. So alkali aggregate reactions, so what are the salt content which comes and which gives the efflorescence without of drying. So since amorphous silica is common component of many coarse aggregates such as alkali aggregates, reaction may create harmful effects on cement concrete. This is because the gel-like silicate structure produced by the above reaction are quite weak and unstable and results in great expansions. So if you see, this is because of alkaline reactions compaction. So dimension stability creep. So creep is defined as the behavior of concrete under loads. This is now well established that concrete is not truly elastic material. Also it is not extremely the plastic material. When hardened concrete is loaded, it deforms. So partly the result is elastic strain. When it is results in plastic strain, permanently deformation used to happen. So its latter non-elastic time dependent formation is a typically property of concrete and is commonly referred as creep. So among various causes of creeps and fall that are mentioned, these are the things that concrete mix may higher water cement ratio will also give higher rate value. So it depends on every aspect of concreting. So shrinkage means plastic shrinkage, drying shrinkage, thermal shrinkage are there in hardened concrete. So if you see what is plastic shrinkage, this is the shrinkage that freshly placed concrete undergo till it sets completely and called initial shrinkage. So a drying shrinkage means as the concrete has been completely set and hardened, some further shrinkage may result and gives the dry. So after drying also certain shrinkage used to happen, that we call it as drying shrinkage. So thermal shrinkage means it is based on the temperature when it contracts or laid or exchanger with the temperature. That type of shrinkage we call it as thermal shrinkage. So expansions, so concrete may expand the hardening due to the following two types: thermal expansion and when the copper laid on the before or low layers are completely set, we call it as thermal expansion. Thank you. Next class we are going to learn about different special types of concrete. Thank you.